Hey guys, Will here. So today I want to tackle a question that gets asked both of me personally as well as something that I see crop up on the internet an awful lot. So the question is, what are the best settings for my Fanatec wheelbase, whether it be a DD1, DD2, CSL Elite, or a CSW 2.5, whatever it is, for whatever sim title you're interested in playing and whatever car you're interested in driving. Now, before we even get started on this video, what I want you guys to understand straight off the bat is that there's no such thing as best settings. Everybody's personal preference is going to vary depending on what car they're driving, depending on how strong they are physically. You know, there's a whole heap of variables that all sort of factor in to this to create the ultimate experience, so to speak. So the focus of today's video and the approach that we're going to be taking today is essentially empowering you with the knowledge that you need to actually come up with the best set of settings or the best configuration for you personally. So the first thing that we'll be looking at is how the data from the sim itself actually gets into your hands through the steering wheel, the process involved there. Then we'll have a look at the options that are available on the Fanatec tuning menu as it stands on the button module endurance, as well as on the DD1 and DD2, so the integrated telemetry module. And yeah, hopefully by the end of this video, you'll be well equipped to come up with the best possible settings to suit your driving style and get the most enjoyment out of your Fanatec wheelbase. So let's get going. Okay, so I've got a little page up here in front of us that explains some basics about force feedback. So we'll read through it and then I'll clarify some of the points as we go. So force feedback effects are generated by motors mounted in the base of a joystick or driving wheel. Pretty obvious there. Through Microsoft's direct input interface, devices are capable to generate those kind of push or resistance in an input device. So that is very poorly written. But basically what that's trying to say is that the direct input application programming interface, or API, is what's used by sim titles to translate information inside the game through to what you actually feel through your hands on the steering wheel. So there's a couple of things that are involved in that process. First, the application or the sim title actually has to create the force feedback information. That can be done either through canned effects, and we'll talk about that in a little bit more detail in just a moment, or physics-based or physics-generated effects. And then that is outputted through the application programming interface called direct input, which is what we just mentioned before. Then that information is interpreted by the drivers and software that you install for your particular wheelbase. The wheelbase then receives that information and decodes it, so to speak, into signals that can be outputted to the motor of the wheelbase. And then the motor responds to those signals, and that's what you feel through the wheel. So obviously in the case of a cog-driven or a belt-driven wheelbase, there's some magic that goes on there with pulleys and cogs and things like that. In the case of a direct drive wheel, basically what you feel is exactly what the motor is generating. So that is the reason why direct drive wheelbases can feel a little bit more grainy than you might be used to with a cog-driven wheelbase, simply because there's a lot more filtering and there's a lot more interpolation. And that's a word that we'll get to know a little bit later on in this video as well. There's a lot more of those sorts of things that need to go on to filter the signal to get it to feel nice and smooth, because you don't have the benefit of a belt or cogs to kind of create a dampening effect and I guess filter those signals out mechanically. So it has to happen through software and drivers and firmware and things like that. So back to the document here, every particular effect, for instance, the engine of a wheeled car, needs to be created separately for every device, and those are called effects. The push or the resistance is called force. So important distinction there. Effects are things like when you run over a ripple strip, the texture of a road, so to speak. And then forces are, the wheel fighting against you as you go over bumps, or through cornering forces, sustained cornering, things like that. So those are two important different types of things that the wheelbase is responsible for: the effects or the texture, and then the actual force of the wheel fighting against you, or the tires and the car fighting against you as you drive. So effects can be categorized into the following categories: a constant force. There's a constant force in a single direction. So say, for example, the wheel turning in one direction and you're kind of fighting against that as you go. A ramping force, or a force that increases or decreases in magnitude. So this could be, as you're coming out of the corner, the cornering force or the constant force slowly reduces. So that's, something that scales up and down as you're turning, or, you might be going over a bump or rubbing against another car, something that is varying in a scale, so to speak. Then a periodic effect is a force that pulsates according to a wave pattern. So this would be something like running over a ripple strip or a corrugated road, something like that. And then a conditional force is a force that reacts to motion or positioning along an axis. So an example of this that they give here is the spring force effect that pushes a joystick back into the middle position. And in the context of a steering wheel, obviously this would be the spring centering force, or the force of the wheel trying to pull back to the center naturally, which is, you know, what you have in a real car. You know that, you know, if you're drifting or something like that, the wheel naturally wants to sort of rotate back to the center. And that's exactly the same kind of effect, which is using a conditional force in this instance. So creating effects can be very difficult, it says, since devices with different motors react differently to the parameters created in the effect. So this is the responsibility of the driver. Obviously, the software, or the sim title to an extent at least, doesn't know what wheel you're going to be using with it. And so therefore it's kind of just outputting the same thing for everything. You can fine tune it obviously within reason, but the software and drivers that you install for your wheelbase is what ultimately is responsible for translating that information into something that makes sense for the mechanical hardware that you have in front of you. So basically what it boils down to is all of the information, all of the data that's coming out of the sim is translated ultimately into these 4 different types of effects, as well as the force of the wheel pulling against you. And that's literally all the direct input system is capable of translating. Everything else that happens is all just through clever trickery using those effects by the sim itself, as well as how the driver and the firmware and software actually interprets that information. So hopefully that makes sense. Let's jump into, we'll close this off and we'll jump into Fanalab now. So we're not going to go through every single aspect of Fanalab here. I do have another video, my DD2 software review, where I went into all the different options like LEDs and all that stuff, how you configure that stuff. All we're going to focus on in today's video is, you know, just the force feedback related features of the software. So if you want to check out more detail on all the other stuff, there's a link in the description below for you guys. One thing I do want to mention here quickly before we do get started though is under profiles on game profile, you can save different profiles for different games. So as you'll see in a moment, we do have the 5 basic profiles that are available and can be switched from the wheel itself, but we can also save and export additional profiles on top of that. So say you want to have profiles for multiple games beyond the 5 that you have access to from the wheel, or maybe you even want to have different profiles depending on which car you're driving inside a game. You can simply set those up, save it, and then export it, send it to your mates even if you wish to do that. So yeah, this gives you a really convenient way of creating multiple profiles for different games, different cars, and things like that. So a really powerful tool there I just wanted to highlight before we get started. But what we're going to be looking at today is the tuning menu and all the different options that are available here. Now these correlate directly with the options that are available through the tuning menu on the wheel itself as well. So if we press on the little tuning menu button here, you can see we have our 5 different profiles which are available here. And you can actually see on the screen as I flick through them on the wheel, it's switching between the different tabs on the Fanalab software as well. Now, if we scroll across on the wheel on, say, profile number 1, we get sensitivity, and this is adjustable right through a scale. We'll look at all these in more detail in just a moment. We get force feedback, we get FFB or force feedback linearity, and so forth. So these all correlate exactly with what is in Fanalab there. So it gives you a really convenient way of adjusting these things. And if we look at, we'll go back to sensitivity again quickly here. You can see as I adjust it here, it's actually adjusting on the screen as well in real time. So we don't have to go back in or alt tab out of the game to make adjustments on the fly, which is really convenient. So let's have a look at the tuning menu here and the options we have available. So we'll click on our profile number 1. Now, before we dive into this as well, I would recommend that you guys jump on the Fanatec forums. I'll put a link in the description below. Specifically, there's a section there where they go through recommended settings for most of the popular sim titles that are around now. And those do give you a really good base point for further fine tuning and adjustment to your own personal preference. So I would definitely recommend using those as a starting point and then fine tuning from there. I will also quickly mention too that even though we are using Fanalab for today's demonstration, the same options that you're going to be seeing under the tuning menu are available in the base driver software as well. So you don't need to have Fanalab installed. Now I do recommend that you do install it because it does give you some extra functionality, which we will be having a look at in today's video in a little bit of detail. But yeah, you can do most of what you'll be seeing in this video in the base driver software as well. So let's get going. First of all, we have our sensitivity, SEN, or maximum steering angle. So this is the amount of sensitivity that we have as we turn the wheel, or how far the wheel turns from bump stop to bump stop, so to speak. Now, a lot of people ask, why does this number go up so high? And as you saw before when we were tweaking it, goes all the way up to a massive 2,520. Now, I actually asked Thomas, the CEO of Fanatec, exactly why this is. And he said a lot of people that do trucking simulation are buying these wheelbases. So obviously when you're driving a truck, you want to be able to turn and turn and turn. So that's the reason why we have that option. But usually you're able to sort of leave this on automatic setting. Basically what it is it's how far you turn the wheel and how that amount of turn is translated into the game. So what you want to have is basically the amount of turn that you have physically matches the amount of turn that you have in the game. So generally what I do is I have the wheel and the hands visible on the screen, and I just adjust this until it looks the same in both, so physically as well as on the screen. So for most titles, Assetto Corsa, iRacing, ACC, I've found generally you can just leave this set to automatic and it's perfectly fine. For the F1 games, so F1 2019 and F1 2020 that's just come out recently, generally set this to 360 degrees, and that gives me a pretty realistic amount of sensitivity. For some of the tighter tracks, I actually like to adjust it down to 320 degrees. So Monaco, for example, just gives me a little bit sharper turn in, a little bit faster reaction time. But just bear in mind as well that if you are adjusting it from track to track, that is going to screw with your muscle memory. So if you're the sort of person that relies very heavily on muscle memory for these kinds of things, as most of us do, just be aware of that. You probably want to keep it set at 360 degrees and not touch it, at least to begin with. And then when you get a little bit more proficient with driving in a particular sim, you can start to fine tune it from track to track. So then we move on to overall FFB strength, or force feedback strength. So this is like our master gain on an audio system. So this is what determines our maximum level of force feedback, and all the other filters and adjustments fall underneath this. So obviously the only thing that influences this externally is the level of force feedback that you set, or the gain level that you set inside the sim itself. Now, I see a lot of people saying that you should set your game force feedback level to 100% and then adjust the level on the drivers to suit your preferred level of strength. Now, I don't always agree with that. Generally, it works with cog-driven and belt-driven wheelbases. On direct drive wheelbases, you can start to run into some software clipping, and basically what's happening is it's similar. Think of if you're using a preamp on a headphone system or something like that. So you've got an iPod or an iPhone or whatever device plugged into a preamp and then going to your headphones. So if you turn the volume on your phone all the way up, then it's already sometimes pushing the limits of the voltage output of the headphone circuit that's actually on the device. So what happens then is it goes into the preamp, and that ends up amplifying a signal that's already clipping a little bit, and all you're doing is you're just creating mud, creating a amplification of a signal that is already dirty. So generally what I like to do with direct drive wheelbases is set my force feedback strength in the game to around sort of 60 to 85%, something like that, and then fine tune my overall force feedback strength in the drivers to suit my overall strength that I actually want to feel. And then what I do is I adjust my force feedback strength in the drivers to the maximum amount of force that I ever want to feel. So under, a crashing scenario, hitting a wall, hitting another car, something like that. But the most important thing to avoid here is clipping. And clipping is basically just as simple as soon as you amplify the signal to the point where it's no longer a clean sine wave, it starts to become a square wave. What's happening is the signal is just distorting, exactly the same as if you turn your headphones up too far and you start to lose the detail in the sound, you begin to lose the detail in the force feedback, exactly the same thing. And then next up, we have this little guy here called linearity. So the tooltip here, and I do encourage you to read these tooltips as you go, because they pretty much explain exactly what I'm explaining, just in more generic terms. So linearity off, which is the default setting, allows maximum peak force. Due to the nature of holding and peak forces, this can cause non-linearity during long sustained high holding forces like cornering. So on reduces overall force feedback force to a level which generates linear behavior between peaks and holding forces. Now, we talked about this a little bit the other day when I did my DD1 versus DD2 review, and I was talking about dynamic range. So I would encourage you to check that video out. I've got a link in the description below to the specific part of the video that I'm referring to here. But basically what we want to have is as linear a response throughout the entire dynamic range of the wheelbase. So the dynamic range of a DD1, for example, is 15 Newton meters. So from 0 to 15 Newton meters for holding, and then from 0 to 20 Newton meters for peak. DD2, by comparison, is 20 Newton meters for holding, 25 Newton meters for peak. So without going into too heavy technical detail, when we turn the linearity on, what it's doing is it's scaling everything down so that we have a nice linear response throughout all the different types of effects. So everything from, you know, minor details in road surface or textures in the road to running over ripple strips, all the way through to, you know, banging into other cars and walls and sustained cornering and stuff like that. So with a direct drive wheelbase, generally I find it's best to leave this turned on because there's enough overall strength there anyway, and you want to have a nicely sort of, you know, balanced scale of force feedback throughout the entire dynamic range. When you're driving with a belt-driven wheelbase or something like that, you've got less dynamic range available to begin with. So say, for example, a ClubSport Wheelbase 2.5, that's about 7.5 to 8 Newton meters of dynamic range. Compare that to a DD1, half the dynamic range, you know, for constant force, and, you know, almost a third, just under a third for peak force. So you have less dynamic range to play with. So therefore you turn off linearity, so you get those really strong bumps and grinds and stuff like that, but you don't lose out on the detail. So what it's basically doing with linearity off is it's amplifying those weaker signals so that you're feeling those a little bit more, and then effectively squashing down those higher amplitude signals so that you still feel strong detail in the lower stuff, but then you're also, you know, not clipping in the higher stuff. So yeah, basically cog-driven, belt-driven wheelbases, leave linearity turned off. For direct drive wheelbases, generally I would recommend having that turned on. So next up we have natural damper. So NDP or natural damper, and we'll scroll across to that on the screen here as well. Adjust a constant damper which is not influenced by the game. So this is a filter that runs on the wheel itself independently of whatever signals are coming in from your sim. So default is set to 50% to prevent oscillations. And oscillations is that weird behavior you sometimes get when you're driving down a straight, you let go of the wheel and the wheel starts kind of going from side to side like crazy. So adding a little bit of damper can actually cancel that out. I generally find adjusting the force feedback intensity and the interpolation setting is the best way to deal with that first, because that's you know, that gets rid of the problem without sort of introducing other effects or other sort of feelings into the equation, but we'll talk about that a little bit later on. But generally for damper, I have this set to around sort of 20 to 50% depending on the game. Now you do have a damper setting inside the game itself as well. So generally, well, for most games anyway. So generally speaking, I like to try, and I keep on saying generally speaking, I apologize for that. Generally speaking, I like to try and set the damper inside the game first and leave this as low as I possibly can. And only if I'm finding I'm not able to achieve the feeling that I want, then I'll go and start adjusting it in the driver software. So this is generally going to be pretty low for me. We'll set it off now for the purpose of what we're doing here. And then we move across to natural friction. So natural friction is the friction or the force of the wheel fighting against you without any other forces in effect. So again, this is running independently of the game itself or the data that's coming out of the game. And you'll find that most sims these days at least generate this through effects themselves. So there's weight that is added to the wheel naturally when you're playing a game without having to add anything additionally here. So for most sims, I'm able to leave this at 0. If I find the steering feels a little bit too light, so some cars, for example, that have really powerful power steering, sometimes the wheel feels a little bit toy-like and a little bit too loose. And in those instances, I'll add a little bit of natural friction just to make it feel a little bit stiffer. So you can see here, it's spinning really, really easily. If I crank that up to 100%, suddenly it's quite stiff and hard to turn. And you can imagine, you know, while that feels, you know, that sort of simulates the weight of a steering rack in a real car, it's, you know, it does slow down your reaction time because there's weight to changing direction quickly. So, you know, in scenarios where you're wanting to be able to flick the car from side to side, change direction real quickly, you generally want to have that set lower. And I know that, you know, the majority of the really fast guys that tend to have their force feedback turned down pretty low, so they're only feeling the things they need to feel and not sort of having to fight against the car. That's the reason they do that, because they're not wanting to make it any harder than it has to be. They're just wanting to feel the details that they need to feel to be able to drive quickly. So natural friction, I generally keep at 0 unless I'm driving a car that is particularly light, and then I might crank it up as far as maybe like 20%. I don't think I've ever needed to turn it up more than 20% on any wheelbase that I've ever used. That's including Fanatec, Logitech, Simucube, you name it. I've never really needed to go higher than that. So next we move on to natural inertia. So natural inertia simulates the additional weight of the steering axis. Higher values will make the wheel feel heavier than it is. This can help making natural friction feel a little bit less sticky. Inertia can hinder oscillations from starting, but will make already happening oscillations worse. So too high settings can slow down reaction and reduce feel. So very similar to what we were just discussing with friction. So if we turn that all the way down and then turn the wheel, you can see it's spinning freely there, but that is literally just the inertia of the weight of the wheel itself and the shaft spinning in the assembly. That doesn't feel artificial at all. That's just the natural weight. If we crank that up then to 100%, you can see now I give the wheel a tiny little nudge and it almost feels like a perpetual motion engine. It just keeps on spinning pretty much forever. So it does feel quite nice. You know, it kind of gives that simulated feeling of the weight of a steering column in a real car. And particularly for drifting, it feels quite nice because it allows the wheel to sort of slip through your hands. But, you know, cranking this up is going to dampen the textures and the response of the car in other ways. So I can't think of a scenario where you would ever want to have this cranked up above maybe 50% if you really want to feel the weight of a car underneath you. But again, because a lot of sims do take care of this themselves, you generally don't need to go much higher than, I generally keep it around about 10, maybe 20%. Very rarely go any higher than that unless I'm driving something really obscure. So next we go to force feedback interpolation. Now, this is a filter that was added more recently, and this was a real game changer. I mentioned this when I did my review of the DD2 back about 6 months ago, and this brought the DD wheelbases from Fanatec a lot closer to the feeling of the Simucube wheelbases, the Simucube 2s, I should say, in my opinion. So basically what this is doing is this is interpolating data between packets of data as they come out of the sim title itself. So you can imagine the force feedback that's coming out of a sim is limited to a certain refresh rate, just like the signal that's coming out of a graphics card is limited to a certain refresh rate for your screens. So say, for example, in the case of iRacing, we have a force feedback refresh rate of 60 Hertz, whereas we might have a refresh rate on our monitor of 240 Hertz. So basically what's happening in that instance is we're getting 4 times the amount of frames on the screen to the amount of packets of data that we're actually getting for our force feedback. So effectively, our screen is refreshing 4 times more than our force feedback does. And that can lend itself to a slightly robotic feel through the steering wheel, because obviously it's, you know, you've got 4 frames before a new packet of data comes in and then it adjusts. And then you've got 4 more frames, adjust, 4 more frames, adjust. Now, it's happening incredibly fast, so you don't really interpret it in terms of, you know, being jerky, so to speak, but it can kind of give it that slight robotic feeling. So what the interpolation filter does is it interpolates or creates simulated packets of data in between the real packets of data. So it's saying, okay, I've got a force feedback strength of, say, 10 Newton meters, and then the next frame is, say, 20 Newton meters. So it sort of goes, all right, well, I know that somewhere in between the two is going to be about 15 Newton meters, so I'll simulate that, and that creates a more granular or more smooth movement through that data. So this setting is going to vary greatly depending on the sim title that you're playing. In the case of iRacing, I generally find a setting of around about 8 feels pretty good to me, because obviously iRacing, as I just said, has a lower refresh rate for force feedback to begin with. If you compare, say, Assetto Corsa Competizione, for example, I think that's 344 Hertz, something like that. So much more data coming out of the sim, much less need for an interpolation filter to begin with. So ACC, I crank this all the way down to 0 and it feels just as smooth as iRacing does. Now, again, obviously, if you have the data available out of the sim, you want to use it. Obviously, real data is always going to be better than interpolated or simulated data. So in the case of, you know, instances where you have that data available, crank the interpolation filter all the way down, or just crank it down to the point where it feels nice and smooth, because obviously the higher you put it, the more kind of dampened and filtered things are going to feel overall. It starts to, you know, get through the robotic feeling, but it does remove a little bit of the detail that you feel in the force feedback. So again, it's a personal preference thing, as is everything here, but that is my recommendation there. So next up, we have force effect intensity. Now, this setting, a lot of people will be familiar with because they're often told to turn it down if they're having problems with oscillation and vibrations and loud metallic noises coming from the wheelbase. But most people don't understand what it actually does beyond this. So this is a filter or an amplifier, so to speak, a preamp for the force effects that are coming out of the direct input driver or the direct input application programming interface directly. So independent of the force feedback or the forces fighting against you. So effects like rumble strips, road textures, and so forth are going to be affected by this independently of the overall forces. That is assuming that the game that you're playing uses canned effects that are actually using those 4 things that we talked about earlier in the videos. So for this setting, I normally leave it set at 100, and with all the other filters that we have in place, it feels pretty good. But if you're finding that bumps in the road just feel too strong compared to the cornering forces and stuff like that, a lot of people are tricked into, bumps feel too heavy, so they end up turning down their overall force feedback strength, but then the cornering forces don't feel strong enough. So it's sort of a bit of a balance between this setting and the overall force feedback strength. You want to have your force feedback strength high enough that the cornering forces feel good, but then the FEI setting low enough that the bumps in the road, the ripple strips and the textures and things like that don't feel too strong. So it's a balancing act between the two. And as I said, I generally find I'm able to leave this at about 100. Some instances I end up turning it down to maybe as low as 50. Once you go down below about 50, it starts to feel really muted, really dampened, and just, you lose that detail and that fidelity that you really want, particularly with a direct drive wheelbase. So generally I would recommend don't go lower than about 50%. Try to leave it at 100% unless you really need to adjust it, but always adjust this before you adjust your overall force feedback strength if you're finding that it's just bumps and textures that are too strong and you don't want to reduce your overall cornering strength. So moving on now to game force effects strength, or FOR. So FOR adjusts the strength of force effects coming from the game. Default is 100%. So games use this effect to control most of the force feedback. Some games only use force effects. And this is what we were talking about earlier with those 4 different types of effects that come out of the direct inputs API. So for games that use canned effects in particular, this is going to be very useful. So if you're finding that those effects are too strong, again, you can use this as a filter for just those things. And that's pretty much all there is to it. So 100%, as it says here, will use the maximum amount of torque selected by the overall strength, and 50% will only use half of the torque selected by the overall force feedback strength. So it's kind of like a sub filter that operates only on that particular, on those particular 4 inputs from the game itself, as opposed to an overall overarching master volume, so to speak, that we have here with our overall force feedback strength. So then we have the more basic settings underneath that. So SPR, as we go across here, is our spring effect. That is the centering spring force, or how strongly, is that the right word? Strongly? How intensely the wheel is trying to force itself back to the center position, how hard you have to fight against it. Now, again, with this setting, most sim titles have their own force, have their own spring effects built into them. So you generally don't have to touch this setting. I usually just leave it at 100%, and that allows whatever's coming out of the game to just do its thing. If you find that you need to boost it for any reason, you can crank it up. If it's too strong, you can crank it down. But generally, you're able to adjust this in the game itself, so there's not really any need to adjust this from 100%. And same deal again here with damper as well. This is a sub-filter for adjusting the damper signal as it comes out of the sim title. So again, generally you'll want to adjust this in the sim first, on this filter second, and then you can adjust your overall natural damper to, fine tune to your taste. So yeah, it really, again, I don't really find any need to adjust this really ever. I find that between the natural damper setting and the damper adjustment that we have available in most games, there's really no need to adjust any further than that. So leave it on 100% unless you have compelling reason to do otherwise. So the last 2 settings don't really relate to force feedback, but we'll go through them quickly as well. We've got our brake pedal vibration threshold. This is the ABS setting. So if you're using V3 pedals, or pedals that have a vibration motor in them, you can set this to be the braking force pressure, at which point the vibration motor kicks in to let you know that you're locking up. So this is a little bit gimmicky in my experience, to be honest, simply because every single car is going to have a different point where it's going to lock up under braking. And, you might think, well, that's fine then, because you can just set up a different profile for each different car. But of course, different road surfaces, different tires, different temperatures for the track, whether it's wet or dry, oily, all those variables all affect at what point the car is going to lock up. So, this isn't variable enough to account for that in any way. So yeah, this setting, I normally don't use the vibration motors in the pedal for that reason, based on this system at least, simply because it is a static thing. It's basically saying whenever you put on 80% or 70%, 60%, whatever you set it, that is the point where the vibration motor is going to kick in. So really what you want to be doing is using third-party software like, for example, SimHub or Fanalab, I think, does it as well. And that actually allows you to have the vibration motors kick in based on the car actually locking up in the sim rather than just a percentage of application. And that is, in my opinion at least, the far better way of going about using those vibration motors. So I generally leave this set to off in Fanalab and then rely on a third-party piece of software to control this for me externally. And then the next setting is our vibration strength for the rumble motors in your wheel. So some of the Fanatec wheels actually have vibration motors built into them, and this is very self-explanatory. It's literally just the adjustment that controls that. So we've got a couple of other little tabs here as well, which we'll just quickly skim over. We've got our multi-position switch adjustments here. So we've got an automatic setting, a rotary encoder setting, and that basically adjusts the wheel so that every time you turn, it's either pulsing up or down. So it's adjusting for an up or down movement, but it doesn't actually know where it is or what setting is currently selected. Then we have a constant, which allows the sim to know constantly what position the switch is in. So you can actually assign it so that number 11, for example, is always engine mode 11 and so forth, as opposed to, every time you turn it, it's just adjusting by one. And that can be particularly useful if you're, changing between different menu options, things like that, because what can happen is, one might not always be one the next time you go in because you might have exited out of the game and then gone back in. So that's sort of the difference between how a rotary encoder works and a multi-position switch works. And then we have pulse as well. And this is generally only used in scenarios where the game isn't compatible with the constant mode. So yeah, that's the difference there. We won't go into a whole lot of detail here now because we have covered that before in other videos, which I've linked in the description for you guys. And then we have our advanced paddle module adjustments here. So we've got the setting for clutch bite point mode, which as you guys have seen before, we'll quickly exit out here, allows you to adjust the bite point for the clutches. We've got clutch and handbrake mode, which allows us to use it as a clutch and a handbrake, as an analog axis, brake and throttle, self-explanatory again, a brake and a throttle. So that's really useful for people that might have injured themselves or have a disability where they can't use pedals. And then we have mappable axes as well. So you can adjust those or map those two analog axes to whatever function you want within the game. And that is pretty much it for the tuning menu. Now, one more really important thing that we do need to discuss before we sign off is dynamic force feedback. So we talked about before how the direct input API is limited in the number of effects that it has access to, and it can only sort of use the direct input side of the data that's coming out of the sim to generate the force feedback effects that you feel through the wheel. Now, we do have all that other telemetry that you guys would have seen in the past, things like what VRS uses to, do all the logging, things like that. And what we have here under dynamic force feedback is the ability to actually use that telemetry data beyond what's available through the direct inputs interface to generate some additional effects. So we have speed sensitivity here, speed threshold. So this allows us to increase a damper effect based on the speed of the vehicle. So this allows us to make the steering feel a little bit lighter or heavier or dampened. And that's because, the faster you're going, the less texture you feel in the road surface in real life. And this allows us to actually account for that in the sim as well. And in my experience, it actually does work pretty darn well. So I usually have this set to what you can see here basically. So a threshold of about 100 kilometers an hour. So we have two thresholds here. We have our damper effect range. This is the, what does it say here? The range of the wheel angle away from the center within the dampening overlay takes effect. That's not very good English at all. But basically what it's saying is, how far you have to turn the wheel from center before it starts to take effect. And I find, for me, again, it depends on the car I'm driving, the track I'm driving, so to speak. So, somewhere around about 100 degrees, I generally find feels good because generally you're going to be going pretty slow anytime that you turn beyond about 100 degrees. But again, very much a personal preference thing. Experiment with this, find the point that feels good for you. There's no right or wrong setting. And then we have the threshold for the effect itself. So the maximum strength of the dampening overlay. And again, this is completely arbitrary. Just set it to whatever you feel feels best for you. And then we have exactly the same things again for when we're driving in reverse. So it's able to reduce the shaking and oscillation and things like that when we're driving in reverse for any reason. So, there's not a whole lot available there, but it is useful and it does make a genuine difference. And I think that, we're only sort of just scratching the surface here. I think we will see a lot of additional stuff here added over time, hopefully anyway. So that pretty much sums up my basic tips for setting up force feedback on a Fanatec wheelbase. As I mentioned before, I do have a similar video where we go through the same thing for Simucube wheelbases as well, but the fundamentals are pretty much the same for any wheelbase. They all rely on those, those values that we talked about before through the direct input API to do all their magic and create the forces that you feel in the game. So hopefully you now feel well equipped to get in there, dive in, and don't feel so intimidated by all these settings, and you can get in there and really extract the most out of your wheelbase. So leave a big fat thumbs up if you've enjoyed the video. I really do hope that this one has helped a bunch of people out. And let me know in the comments as well if you have anything additional that you'd like to add, any questions that you'd like answered. I do read all of the comments and try to respond to as many of them as I possibly can. If there's anything you think I've left out as well, let me know in the comments and I'll be sure to make a future video to fill you in on that as well. But thank you very much for watching, guys. And make sure you subbed if you haven't already so you don't miss future videos. And I think that's pretty much it. So I'll see you guys again soon. Bye.